I'm Ryan Nickel, CTO at DSA Ocean, and today we're going to talk about how to generate and export a Motion RAO database and use it in the Ship Motion toolbox. This is a key point of input for the Ship Motion toolbox for which you can do an ISO compliant motion comfort assessment. What we're going to use is the sample generic yacht files for the ProteusDS ShipMo3D toolset. You can download these off our website. And when you open them for the first time, this is the kind of thing that you should see. We have our main project panel here, and you'll have to go through and add the existing data for all the project files. They're all path specific, so you have to go through them and add them. So we have the panel hull input. You want to make sure that all the files that it's referencing are referenced relative to your local directory here. Open that file there, and you can run this to generate the wet and dry mesh. So there's our 50-meter hull with a displacement in yellow. And then we go to lid, panel lid. We use the wet panel hull we just made. The default, otherwise the default parameters should be just fine. This is facilitating a preparation for the radiation and diffraction calculations. So we'll open raddiff, and we'll open the raddiff input file that's already configured here. Let's make sure that these files are pointing to the right folder location that you have on your computer, wherever you've downloaded these. This will take a little bit of time, so we'll run the raddiff values and check in on it again shortly when it's done. Okay, that's completed. If you like, you can take a look at the radiation diffraction plots. They're pretty smooth and looking good. We then go to build ship. Open the input file here. Again, making sure you've got these files relative to your local path that you're working with. And we'll run build ship. So at this state, the files are pretty basic. They don't have anything else other than the hull set up and the radiation and diffraction values, which is totally fine, especially for a seakeeping analysis, a basic bare hull seakeeping analysis. The next thing we want to do is add seakeep regular. This is going to calculate the ship motion in regular waves. In other words, for the motion RAO. Normally what you would do is if you want to evaluate ship motion in a wide range of sea states, you might want to consider using a wider range of relative headings and directions and frequencies. This will cover relative headings from head sea to following sea. 0 to 12 knots would be the minimum speed as well. So we'll run that. And what you want to do is make sure you have export ProteusDS response amplitude operators checked. So we'll save that and run that. It'll just take a moment. And you'll see here it just says, hey, there's this .dat file here. So if you like, you can look at the motion RAO files that you've generated for different speeds and different relative directions. But what we want to do is use the file that's generated. You can see it here. And what we're going to do is load that into the Ship Motion toolbox here. So we'll just make sure we've got that file that was just generated here. I've pre-populated the locations of the areas for the owner's cabin and dining area and so on. And we'll perform the comfort analysis. So the ISO 22834 standard says to use 0 knots and 12 knots to calculate the comfort rating, and it's all calculated at a bow quartering condition, 135 degrees. And you can see here we have the motion comfort rating, the individual comfort ratings at each location. Of course, the overall comfort rating is an aggregate of all of these values for 0 knots and 12 knots. And then you can look at the individual values across the different sea states here. These are the different sea state periods, and so at 0 knots or 12 knots, and the two criteria are motion sickness incidence and effective gravity angle. You can take a closer look at that. But really what I wanted to do is just kind of show the steps in going through and calculating the motion RAO. Of course, you can go back here and make adjustments to the position and recalculate another value, but we'll show more about that in other tutorial videos. All right, thanks for watching.